Imagine this. You're looking up at the night sky, a vast canvas of stars and galaxies, and for a moment, you feel like something's looking back. It might sound like science fiction, but some astronomers are exploring the idea that the universe might be more aware of us than we think. What if the cosmos isn't just a silent, empty void? What if it's watching, learning, and maybe even responding? This isn't about little green men or flying saucers. It's about the strange, mysterious, and downright mind-bending possibilities that emerge when we start to consider that the universe might be more interconnected than we ever imagined. So, are we truly alone out here, or is the universe paying more attention than we realize? Let's dive in and explore why some astronomers believe space might be watching us back, the unsettling idea behind the belief, why certain observations make scientists uncomfortable rather than excited. The notion that space might be watching us back isn't just a plot point from a science fiction movie. Some astronomers have raised eyebrows and sparked discomfort with observations that hint at unusual patterns or anomalies in the cosmos. These observations aren't necessarily about little green men with telescopes pointed at Earth. Instead, they revolve around phenomena that don't fit neatly into our current understanding of the universe. For instance, the famous WOW signal detected in 1977 was a strong radio signal that lasted for 72 seconds. It was so unusual that the astronomer who discovered it wrote "wow" on the printout. Despite extensive search efforts, the signal was never detected again, leaving its origin a mystery. Such events can be unsettling because they challenge our scientific frameworks and leave us with more questions than answers. One of the reasons these observations make scientists uncomfortable is the lack of repeatability. In science, repeatability is key to validating findings. If a phenomenon can't be observed again under similar conditions, it's hard to draw conclusions. This is why some astronomers are cautious about jumping to conclusions, even when faced with intriguing data. For example, fast radio bursts, FRBs, are intense pulses of radio waves that last for just a few milliseconds. Since their discovery, hundreds of FRBs have been detected, but their exact cause remains unknown. While most scientists believe FRBs have natural origins, the uncertainty can be unsettling. It's like hearing a strange noise in the night. You might have a logical explanation, but until you're sure, it's hard to shake off the feeling of unease. Another factor that adds to the discomfort is the vastness and complexity of the universe. Space is filled with phenomena that we are only beginning to understand. Take dark matter and dark energy, for example. These invisible components make up about 95% of the universe, yet we know very little about them. Their existence is inferred through their gravitational effects on visible matter. This lack of direct evidence can be unsettling, as it reminds us how much we don't know. It's like being in a room full of people speaking a language you don't understand. You can sense their presence and see their actions, but you can't grasp the full picture. This uncertainty can make some scientists feel like they're missing something big, something that might be watching us back. Moreover, the idea that space might be watching us back touches on deeper philosophical and existential questions. It challenges our place in the universe and our understanding of reality. For instance, the Fermi paradox questions why, given the high probability of the existence of extraterrestrial civilizations, we haven't found any concrete evidence of them. This paradox can be unsettling because it highlights the vast gap between our expectations and our observations. It's like planning a surprise party and having no one show up. You start to question your assumptions and wonder what you might have missed. This discomfort can drive scientists to explore new avenues of research, pushing the boundaries of our knowledge. Some astronomers have noticed patterns in the cosmos that seem too deliberate to be mere coincidences. These patterns often manifest as strange alignments, repeating signals, and statistical anomalies that challenge our understanding of the universe. For instance, the WOW signal detected in 1977 was a strong narrowband radio signal received by Ohio State University's Big Ear radio telescope. It lasted for 72 seconds and appeared to come from the direction of the constellation Sagittarius. The signal was so named because the astronomer who discovered it, Jerry R. Eman, wrote "wow" on the printout. The signal's intensity and duration were unusual, and its origin remains unexplained. Despite extensive searches, the signal has never been detected again, adding to its mystery. Another intriguing example is the fast radio bursts, FRBs. These are intense pulses of radio waves that last for a few milliseconds. Since their discovery in 2007, over 100 FRBs have been detected. What makes them peculiar is their repetition. Some FRBs repeat in a seemingly random pattern, with intervals ranging from minutes to hours. The most famous repeating FRB, FRB 121102, was found to repeat every 157 days. The regularity of these repetitions is striking and has led some to speculate about potential artificial origins. However, most scientists attribute these patterns to natural astrophysical processes, such as highly magnetized neutron stars known as magnetars. Statistical anomalies also pique the curiosity of astronomers. One such anomaly is the Fermi paradox, which questions the high probability of the existence of extraterrestrial civilizations and the lack of contact or evidence for such civilizations. This paradox is based on statistical calculations that suggest there should be many advanced civilizations in our galaxy alone. The absence of any confirmed contact or evidence has led to various hypotheses, including the zoo hypothesis, which suggests that extraterrestrial civilizations might be deliberately avoiding contact with us. While these ideas are speculative, they highlight the intriguing patterns and anomalies that continue to puzzle astronomers. Observer-dependent phenomena, measurements that seem to change based on how and when they are observed. Quantum mechanics, the branch of physics that deals with the smallest particles in the universe, has some bizarre implications. One of these is the idea of observer-dependent phenomena. This means that the act of observing or measuring something can actually change the outcome. It's like trying to take a picture of a shy animal. The moment it notices you, it changes its behavior. In the quantum world, this isn't just a metaphor. Particles can exist in multiple states at once, a concept known as superposition. But as soon as you measure them, they choose a state. This is what's known as the observer effect. Take the classic double-slit experiment. When tiny particles like electrons are fired at a barrier with two slits, they create an interference pattern, as if they're waves. But if you try to observe which slit each electron goes through, the interference pattern disappears, and the electrons act like particles instead. It's as if the electrons know they're being watched and change their behavior accordingly. This isn't just a quirk of electrons. Similar effects have been observed with photons, the particles that make up light. This might seem like a strange and abstract idea, but it has real implications. For instance, it's why we can't have perfectly accurate measurements in the quantum world. Every measurement disturbs the system to some degree. It's also why technologies like quantum computers have to be kept at extremely cold temperatures. Heat causes particles to vibrate, which is a form of observation, and this can disrupt the delicate quantum states that these computers rely on. So, in a sense, the universe is always watching, and what it sees can change the very nature of reality. The role of advanced telescopes, deeper observation leading to stranger and less predictable results. Advanced telescopes have opened up a window to the universe that was once unimaginable. These powerful instruments, equipped with cutting-edge technology, allow astronomers to peer deeper into space than ever before. The Hubble Space Telescope, for instance, has captured images of galaxies billions of light-years away, revealing a cosmos that is far more complex and mysterious than previously thought. With each new observation, the universe seems to throw up more questions than answers. One of the most significant advancements in telescope technology is adaptive optics. This system uses deformable mirrors to correct the distortions caused by Earth's atmosphere, providing clearer and sharper images of distant celestial objects. The Keck Observatory in Hawaii, for example, uses adaptive optics to study exoplanets, which are planets orbiting other stars. These observations have led to the discovery of planets with unusual characteristics, such as those with diamond-like compositions or atmospheres filled with exotic chemicals. Deeper observation has also led to the discovery of strange and unpredictable phenomena. For instance, fast radio bursts, FRBs, are intense pulses of radio waves that last for just a few milliseconds. These bursts were first discovered in 2007, and their origin remains a mystery. Some scientists speculate that they could be caused by highly magnetized neutron stars, while others suggest more exotic explanations, such as collisions between black holes. The more astronomers observe, the more they realize how little they know about the universe. Moreover, the James Webb Space Telescope, launched in 2021, promises to push the boundaries of our understanding even further. With its infrared capabilities, it can observe some of the most distant events and objects in the universe, such as the formation of the first galaxies. This telescope is expected to provide insights into the early universe, the life cycles of stars, and the atmospheres of exoplanets. As we delve deeper into the cosmos, the results become stranger and less predictable, challenging our existing theories and models. Cosmic coincidences that defy probability, events occurring exactly when humanity looks in specific directions. The universe is vast, and the odds of specific events happening at the exact moment we observe them seem astronomically low. Yet, there are instances where cosmic events have aligned with our gaze, sparking intrigue and debate among astronomers. One such example is the discovery of exoplanets. When we point our telescopes in certain directions, we find planets orbiting distant stars. The probability of detecting these planets at the precise moment we look is incredibly slim, yet it happens. This isn't a suggestion of some grand design, but rather a reminder of how vast and dynamic the universe is. Consider the case of gravitational waves. These ripples in spacetime, predicted by Einstein, were first detected in 2015. The event, caused by the merger of two black holes, occurred just as our advanced detectors were finally sensitive enough to pick up such signals. The timing seems almost too perfect. Similarly, the observation of supernovae often coincides with our ability to detect them. These stellar explosions are fleeting, and catching one in the act requires not just luck but also the right timing. It's as if the universe is putting on a show just for us, even though we know it's happening all the time, everywhere. Another fascinating example is the discovery of fast radio bursts, FRBs. These intense pulses of radio waves last mere milliseconds and originate from distant galaxies. The first FRB was detected in 2007, and since then, more have been found, often when astronomers were looking in specific directions for other phenomena. The probability of these bursts occurring exactly when and where our telescopes are pointed is astonishingly low. Yet, here we are, detecting them. It's not that the universe is watching us back, but rather that we are becoming better at listening and looking at the right moments. These cosmic coincidences are more about our improving technology and persistence than any grand cosmic conspiracy. As our instruments become more sensitive and our methods more refined, we are bound to catch more of these fleeting events. It's a testament to human ingenuity and our relentless pursuit of understanding the universe. The universe isn't watching us back, we are just getting better at watching it. The idea that space might be watching us back has sparked intriguing philosophical debates. At the heart of these discussions lies the question of consciousness. If there are entities or phenomena in the universe observing us, what does that say about their awareness? Are they conscious beings, or are they merely mechanical observers? This line of thinking pushes the boundaries of our understanding of consciousness. It challenges the notion that consciousness is exclusively a human or even earthly trait. If other entities in the cosmos are aware of us, it might imply that consciousness is a fundamental aspect of the universe, not just a product of biological evolution. Observation itself becomes a fascinating topic when considering the idea of being watched from space. In physics, the act of observation can change the outcome of an experiment, as seen in the quantum mechanics principle of observer effect. This raises the question, if something out there is observing us, could our reality be influenced by their gaze? It's a mind-bending concept that blurs the line between subject and object, observer and observed. It also invites us to reconsider our place in the universe. Are we the main characters in our own story, or are we part of a much larger narrative being watched by unseen audiences? The nature of reality is another profound implication. If space is watching us, what does that mean for the fabric of reality itself? Is reality a fixed, objective entity, or is it shaped by the act of observation? This ties into the philosophical debate between realism and idealism. Realism posits that reality exists independently of our perception, while idealism suggests that reality is dependent on minds perceiving it. If entities in space are observing us, it might lend credence to the idea that reality is, at least in part, a product of consciousness. This challenges our understanding of the universe and our place within it. It also opens up the possibility that reality is far more malleable and interconnected than we previously thought. The astronomy community is a vibrant mix of minds, each bringing unique perspectives and interpretations to the cosmos. This diversity often sparks intense debates, particularly when it comes to unconventional ideas. One such idea is the notion that space might be watching us back. This concept, while not mainstream, has ignited sharp discussions among astronomers. Skeptics argue that such ideas lack empirical evidence and lean more towards science fiction than science fact. They emphasize the importance of peer-reviewed research and the scientific method, which relies on observable, measurable, and repeatable phenomena. For instance, when a study suggests that certain celestial bodies exhibit behavior that could be interpreted as watching, skeptics demand rigorous data to support such claims. They point out that many natural phenomena have mundane explanations, and jumping to extraordinary conclusions can lead to misinformation. On the other hand, some astronomers approach the idea with a more open mind. They argue that science should not dismiss unconventional theories outright but should instead explore them with a critical yet open-eyed perspective. For example, the concept of panspermia, which suggests that life could be distributed throughout the universe by meteoroids, was once considered fringe but is now taken more seriously. Similarly, the idea that space might be watching could be a metaphor for the universe's interconnectedness or the potential for extraterrestrial intelligence. Proponents of this view often cite the Fermi paradox, which questions why, given the high probability of the existence of extraterrestrial civilizations, we have not yet found conclusive evidence of them. This paradox fuels debates and encourages astronomers to think outside the box. The controversy often boils down to the balance between skepticism and openness. Skeptics worry that entertaining such ideas without solid evidence can undermine the credibility of the scientific community. They prefer to stick to well-established theories and data-driven research. For example, the search for extraterrestrial intelligence, SETI, has been a contentious topic. While some astronomers fully support SETI initiatives, others view them as a distraction from more serious astronomical research. This divide highlights the tension between traditional and unconventional approaches within the field. The debate is not just about the idea itself but also about the methods and resources allocated to exploring it. Moreover, the controversy extends to the public perception of astronomy. Some astronomers argue that discussing unconventional ideas, even if just for debate, can make the field seem less credible to the general public. They believe that the public should see astronomy as a rigorous, evidence-based science, not a realm for speculative theories. Others counter that engaging with the public about intriguing ideas, even if they are not mainstream, can spark interest and inspire the next generation of scientists. For instance, discussions about the possibility of extraterrestrial life have led to increased public support for space exploration and funding for astronomical research. This duality showcases the complex relationship between scientific rigor and public engagement. The idea that space might be watching us back has been a persistent theme in both scientific and popular culture. One reason this notion refuses to disappear is the accumulation of unexplained phenomena and data that continue to baffle astronomers and researchers. For instance, the WOW signal, detected in 1977, remains one of the most compelling pieces of evidence. This strong narrowband radio signal appeared to come from the direction of the constellation Sagittarius and lasted for 72 seconds. Despite extensive follow-up observations, the signal has never been detected again, leaving its origin a mystery. Such anomalies fuel speculation and keep the idea alive. Another factor contributing to the persistence of this belief is the discovery of fast radio bursts, FRBs. These are intense pulses of radio waves that last for a few milliseconds. While most FRBs have been attributed to natural astrophysical phenomena, their exact origins remain unclear. Some FRBs repeat in a pattern that is difficult to explain with current astrophysical models. This unpredictability and the lack of a definitive explanation have led to various theories, including the possibility of extraterrestrial intelligence. The fact that these bursts come from distant galaxies adds to the intrigue, as it suggests that whatever is causing them is incredibly powerful. Additionally, the Fermi paradox plays a significant role in keeping the idea of space watching us back in the public consciousness. This paradox highlights the contradiction between the high probability of the existence of extraterrestrial civilizations and the lack of contact or evidence for such civilizations. Despite extensive searches, no definitive proof of extraterrestrial life has been found. This absence of evidence, combined with the vastness of the universe, leaves room for speculation. Some astronomers argue that the lack of contact could be due to various reasons, including the possibility that advanced civilizations are observing us but choosing not to make their presence known. The ongoing search for technosignatures also contributes to the persistence of this idea. Technosignatures are indicators of advanced technology that could be detected from Earth. These include artificial radio signals, megastructures like Dyson spheres, and other signs of technological activity. Projects like the Search for Extraterrestrial Intelligence, SETI, and Breakthrough Listen are dedicated to finding these signs. While no definitive technosignatures have been discovered yet, the continuous search and the occasional detection of intriguing signals keep the hope alive. The possibility that we might be missing something due to the limitations of our current technology adds another layer of mystery. So, to wrap things up, we've explored some mind-bending ideas about whether space might be watching us back. We've talked about the Fermi paradox, the WOW signal, and the intriguing concept of the Great Filter. We've also considered the idea that advanced civilizations might be using cosmic phenomena to communicate or observe us. It's a lot to take in, but it's also a testament to how much we still have to learn and discover about the universe. Now, first know what you might be thinking. This is all a bit out there. Is any of this really true? Well, that's the beauty of science and exploration. We don't have all the answers, and that's what makes it so exciting. Every new discovery, every new piece of data, brings us one step closer to understanding our place in the cosmos. So, what can you do? Keep looking up. Keep wondering. Keep asking those big, seemingly impossible questions. And who knows? Maybe one day, you'll be the one to make the next big discovery that changes everything we think we know about the universe. And hey, if you're as fascinated by this stuff as we are, make sure to hit that subscribe button and turn on notifications so you don't miss our next video. We are diving into even more mind-blowing topics, like the possibility of time travel and the mysteries of dark matter. Trust me, you won't want to miss it. Until then, keep exploring, keep questioning, and remember, the universe is vast, mysterious, and full of wonders just waiting to be discovered. Who knows? Maybe, just maybe, something out there is watching us back. And if it is, let's give it a wave. After all, we are all part of this incredible cosmos together. See you next time, Space Explorers.